Hi, Nancy.
Hi, Shane.
And hi, Kim, who is the producer for this episode. Hi, Kim.
Hi, Shane. Hi, Nancy.
Hi, Kim.
All right.
A lot of
So,
highs.
yeah, we'll just say hi to everyone.
Yeah.
I'll say hi to my dog who's like sitting outside the closet I'm in. Question for today. Does life exist on other planets? Go.
It has to, right? I mean,
Does it?
doesn't it have to? Kim's the expert here, I feel, but
Kim does have
has a
a more of
PhD
a
in
background than
some
we do.
science of space.
Astrophysics, Nancy. Astrophysics. It has a name. I feel like you said, it sort of has to, right? We're here, and we're, sorry to say, nothing special, right?
But like,
We're not the center of the universe, so why doesn't life exist somewhere else?
I mean, given all the planets, all the stars, all the soul, all the universe, all the everything.
Let me
Come
caveat this
on.
then. Do you think that life exists other places under conditions that are similar to the conditions that we have here? Or do you think we have to completely come up with a different way of thinking about what life is or the conditions that would be able to sustain life?
Ooh, now that's a tough one.
Eh?
If you expand it to life can look like anything and exist anywhere, then how would we ever know if we found it?
I know, you wouldn't even
Come
know that
on.
we're life because you're like, that looks like a rock, but it's really a life.
I'm pretty sure
Really,
there are
Nancy?
many Star
This is
Trek
deep.
episodes like
This
that.
is deep. This is getting real deep now.
I'm gonna make that's gonna be a quote. I'm gonna like print it out and like put it on my computer. Like it looks like a rock, but it could be life. Welcome to the American Geophysical Union's podcast about the scientists and the methods behind the science. These are the stories you won't read in the manuscript or hear in a lecture. I'm Shane Hanlon.
And I'm Nancy Bompey.
And this is Third Pod from the Sun. All right. So, as usual, there is a reason why I'm asking this question. And since we already brought Kim in, I'll just go to you, Kim. What are we talking about today? Like, why are we talking about this?
So we're talking about, do aliens exist? Personally, I don't know. We certainly haven't found anything yet. But there are people who are trying to answer that question in a scientific way. And I talked to a couple of the people who are trying to figure it out. And in the process of figuring it out, also modernize how we think about the search for extraterrestrial intelligence and transform it into a full-fledged scientific field.
I'm Jason Wright. I'm a professor of astronomy and astrophysics at Pennsylvania State University, and I'm the director of the Penn State Extraterrestrial Intelligence Center. I work on problems in stellar astrophysics, exoplanetary astrophysics, and the search for extraterrestrial intelligence.
I'm Sophia Sheikh. I am a graduate student at Penn State, getting a PhD, hopefully, in astronomy and astrobiology, and I work in the area of radio astronomy, so sometimes this is on astrophysical objects like pulsars, and a lot of the time it's on the search for extraterrestrial intelligence in the radio.
Right off the bat, I asked them about whether they think that what they're searching for really exists somewhere out there.
I think I'm going to butcher the quote, but the only test of extraterrestrial intelligence is an empirical one. Something along those lines.
That's it. And people seem really sure that if they are out there, there's no way they're going to do anything that we would detect. And, that's an opinion. That's a prior, could be right, could be wrong, but some people really feel very emphatically that they are out there and we'll find them, or they are out there and we can't find them, or they aren't out there. And, I'm a scientist and I like data. And so for all those people out there who are saying there's nothing out there to find, you're wasting your time, well, then I'll put some pretty good upper limits on that.
Jason, I think when most people think of the search for extraterrestrial intelligence, or SETI, I think they picture, Area 51, or Little Green Men, or Jodie Foster with the headphones up to her ear in Contact. That's obviously not what you do. That's not how SETI is done. But what does SETI look like in the 21st century?
Yeah, what does SETI look like? So there's a lot of ways that one can look for extraterrestrial intelligence. The most common is not too far from Jodie Foster with the headphones. And most of the work that's done is, in fact, with radio telescopes looking for radio transmissions. And although it doesn't really make much sense to put headphones on because we're not listening in that sense that you would on an FM dial or something like that, that movie was surprisingly accurate and really tried to get a lot of the details right about what radio astronomy looks like. But it's broadened today, and there's more to it than just radio astronomy. Just as old as the idea that we would find radio transmissions is the idea that we might find laser transitions. That was suggested in 1964, just 5 years after Frank Drake started Project Ozma in the radio, by the Nobel laureate Charlie Towns, who invented the laser. And that looks a lot more like normal optical astronomy that people are familiar with optical telescopes and a camera on the back looking for laser flashes or something like that. But then the rest of it, we are generally looking at archival data. We're not putting a custom instrument on a telescope and doing a brand new observation with that. We're looking at maybe data from the WISE space telescope and all of the archives that it produced, or we're looking at data from the digitization of old photographic plates. And so, like a lot of science today, it's sitting in front of a computer and writing computer programs and getting mad at those computer programs because they're not doing what you think they should, to look through huge amounts of data and look for whatever it is you're looking for.
So they have all this computer programs, all this data. Like, what are they actually looking for in the data? Like, what kind of signal would give them what they want?
Jason explained to me that SETI is very similar to other branches of astrobiology in that both fields look for signs of life in the stars. Most astrobiologists look for signs of any type of life, like bacteria or microbes or plants or something, using what are called biosignatures, like we look for methane on Mars, or recently we found phosphine on Venus.
So it's like a signature of life happening.
Right, it's a chemical signature in the spectrum of a planet's atmosphere. But SETI scientists look for signs of advanced life, like technology or communication. Communication SETI is like what's portrayed in the movie Contact, scientists hunting for or stumbling upon a signal with some sort of information content, something like a lighthouse announcing its presence to ships, or if you overhear someone's conversation, all of those are signs of intelligent life.
Ah, okay, that's the difference. That makes sense.
I love Contact.
Love
I
that
do
movie.
too. It's a great movie.
Matthew McConaughey.
If we ever detect something like that, which we definitely haven't, it will be really clear that what we're seeing was actually created by intelligent life and not from some natural process. Some types of communication SETI, like radio communications for example, might also mean that there's technology involved. That makes it also part of Jason's domain, which is looking for technosignatures.
And this is sometimes called artifact SETI or Dysonian SETI after Freeman Dyson, where we're just looking for evidence of technology. So you could imagine if you were a member of an anthill in the Serengeti and you want to know if there are intelligent species out there on the planet, if you could somehow build a radio receiver and pick up a radio station, then there it is, you're done. There's clearly a radio transmitter. But if what you're looking for is something more subtle, like the clouds behind aircraft going overhead, well, are those natural clouds or are those really the contrails from behind a plane? Or maybe you detect the presence of CFCs or artificial chemistry in the atmosphere. And now you're having debates, well, does that really mean someone out there is making CFCs or could those be natural? And so the nice thing about this approach is that you don't have to assume they're trying to get your attention. You don't have to assume you know how they'll try to communicate. The downside is that even when you find it, you're not sure you've found life. And so one side I think is more likely to succeed because it looks for a broader class of signal, but the other, the communication SETI, is more valuable because that's the only way you'll really know you found it.
Because otherwise there might be some sort of false positive, there might be some sort of non-biotic way for that signal to come about that we just may not know about yet.
Right. It's very similar to the search for biosignatures in the rest of astrobiology, that if you see methane on Mars, That would be really interesting, and that's the sort of thing life would do. On the other hand, you can imagine all of these other processes that might produce methane abiotically, and so you're not necessarily sure you found it. And then I suppose, to complete the analogy, if you actually found the mold growing on the rock underground, that would just clinch it, and now you're sure that you found life.
I have to sidebar here. In between recording this, Kim and I didn't know if Matthew McConaughey was in fact in contact, so we had to do some quick Googling, and kudos to you, Nancy. It turns out he is. And if you actually look at, I just looked this up, his picture, it's him and Jodie Foster, but he's on like the picture of Contact, and I had no idea.
Thank you. Thank you.
But getting back to the episode, I'm interested in, there are so many different ways of looking for alien life, and I feel like this is such a popular thing, at least in our popular culture and in kind of like the non-science public. It seems strange to me that SETI has kind of stayed on the fringes of science, or at least not taken as seriously as I might expect.
You're absolutely right, Shane. I mean, SETI has been around for decades, going back way earlier than people like Freeman Dyson and Carl Sagan and Jill Tarter, who, point in fact, is a real-life scientist that Jodie Foster portrayed in the movie Contact.
Ah, cool.
But for a long time, SETI wasn't actually supported by as a scientific field by NASA or other funding agencies because of congressional pushback. It's politics. So only a handful of people in the US have been working on SETI during the 80s and the 90s and the early 2000s, and only at a few private research centers like the SETI Institute in California. But that has been changing recently, for example, with the establishment of the Penn State Extraterrestrial Intelligence Center, and there was recently a NASA-sponsored workshop on technosignatures.
There's even been a recent success, actually, at the University of Rochester. Adam Frank has had the first successful NASA SETI proposal to do research, not just build hardware, but do research in SETI since forever. So the idea is we're looking at these planets around other stars. We're looking for biosignatures. And the way you do that on a planet around another star is you look at the light that filters through the atmosphere when the planet passes between the star and the Earth. And you look for signatures of metabolism. Like, for instance, you might look for the simultaneous presence of ozone and methane. Because on Earth, those only coexist in the atmosphere because we have both plants and animals doing metabolism and all of that. So that would be a biosignature.
Upcoming telescopes like NASA's James Webb and Europe's Ariel telescopes will be looking for those kinds of biosignatures in the atmospheres of extrasolar planets.
But what if we look at one of these spectra of these exoplanets, and there's something we don't recognize at all? It's not carbon, it's oxygen. What if it's like a chlorofluorocarbon? And the chlorofluorocarbons we've already put in our atmosphere are actually almost detectable. They're not quite. You need about 10 times as much. But you could imagine on another planet they might be. So what would artificial atmospheric technosignatures even look like? No one's really worked it out before. It's an idea, but it's not something you could look for yet.
As this sort of new era of SETI research is gaining speed, what role do you see the PSETI Center playing?
The point behind the PSETI Center was to create that academic home where you do the things that academics do, which is turn a practice into a discipline and create a curriculum and create a canon and create textbooks and advance the field so that people stop reinventing the same ideas over and over again or writing papers without reading all the previous ones and citing them, which is basically what's been going on.
And part of what academics do is train graduate students like Sophia.
If you asked me 10 years ago what I thought I would be doing, the answer would not be looking for aliens. So I was looking for a new research mentor, and I was browsing through Reddit, of all places, and on the front page of Reddit, there was a story about $100 million being given to the search for extraterrestrial intelligence, and I saw the name of the PI, and I didn't recognize the name, but it said he was at UC Berkeley.
I love that she joined the field because she found it on Reddit. Like I work in social media and science communication on social media. I tell people all the time, like, yes, it can be a dumpster fire, but there's some real good stuff out there, and this is a case, I guess, for my argument.
Yeah, it's definitely my favorite career origin story that I've ever heard. So after she found this scientific project on Reddit, Sophia's mentor put her in contact with the PI on the project, and that got the ball rolling to where she is today at Penn State. So in addition to doing SETI research, Sophia took a graduate course in SETI that was designed and led by Jason, and they explored the decades of academic literature on the topic. They discussed and debated the different approaches to the research, and they even designed and executed a real research project where they traveled down to the Green Bay Radio Telescope in West Virginia.
When we started the project at the beginning of the course, about half of the students taking the class decided that that was what they wanted to focus on. So we started with the constraint of we get the 100-meter Green Bank telescope for about 6 hours. What are we going to do with it that is related to SETI? So it was very open-ended to start, and I was not part of the group who designed the observing plan, so I will give credit where it's due. There were other students who came up with this idea. But in the end, the idea was to look at about a dozen stars with known planets around them, and specifically planets that transited their stars as viewed from Earth. So we knew they were there because we've seen the planets transit before, and we wanted to look for radio signals coming from those planets at the time when they were in transit. So this is kind of a special time or a special geometry because the Earth and the planet's star are all aligned. So the idea is that maybe that's a better than average time. If you're going to send a signal, it might be a good idea to pick a time that everyone could figure out. So that was kind of the philosophy behind the search. And that idea of like trying to find a special time that might be more likely is actually an idea in game theory called a Schelling point. SETI is very interdisciplinary, and people had talked about this and given it a bunch of different names in the SETI literature, but it turns out they'd been talking about it in a different field for decades, so oops. But kind of one everyday example of a Schelling point is if you were going to meet up with your friend, but you forgot to specify what time you were meeting up, maybe you would say, well, we're probably going to meet up on the hour, or we're probably going to meet up at noon. It would be weird for your friend to be like, wow, I expected you to meet me at 9:53 and you didn't meet me. There are certain times that are more important or more obvious. And so we're basically applying that same logic to times that are more important or more obvious for signal sending in an astrobiological sense.
So aside from looking for radio signals from exoplanets and wandering interstellar objects like Oumuamua, or looking for heat given off by Dyson spheres, what other ideas are SETI scientists hoping to explore in the future?
I don't know. Sometimes I like to say that the technosignature we'll find first is probably going to turn out to be one that we haven't even thought of yet. And we might stumble across it by accident. So we need to keep an open mind. So I think we're still at the just try everything, grow the field, brainstorm part of this very young field, while keeping in mind that we do have some mature search strategies that we haven't really tried very hard at yet. And that's one of the great things about Breakthrough Listen's radio program, is that we're finally really trying that project. In Radio SETI that, Jodie Foster tried in Contact, but really hasn't been tried very much.
I also have been thinking about gravitational wave SETI a bit recently. Specifically, if you have a very large linearly accelerating mass, aka a spaceship, what kind of gravitational wave signature would that leave? Is it something that we could detect with either current instruments or upcoming instruments? So that's been an adventure of a project. And I think something that I want to move into that I don't actually have on my plate right now is thinking more about anomaly detection in large data sets. Big data is kind of our buzzword right now in astronomy. As in every field, I guess, right now, but especially with kind of really large upcoming survey missions and even current missions like TESS, where you're getting a ton of data coming in that are not explicitly or even implicitly, most people would not think about them for the purposes of SETI. But if we were to find something that we couldn't explain by known astrophysical phenomena in that data set, that would be interesting. It doesn't necessarily have to be aliens, right? And in fact, It's Never Aliens is a common tweet that I stand by. But we can find really interesting things about the universe by finding the things that don't fit our current understanding. And so developing methods to go through these large data sets and pull out things that don't look like everything else is valuable in general for astrophysics, and it's valuable for SETI. And I think that's a really rich area that's going to require a lot of interdisciplinarity between astronomers and data scientists. But you can't have a field where everyone is a senior or emeritus professor. You need to have people at every career stage, or the field isn't going to continue. You need to have these ideas continue to trickle down to people who are moving into the field, but are also moving between different fields interdisciplinarily, or who are fluent in, say, data science and computation.
The fact that SETI as a modernized, rigorous academic discipline is so young means that it's less beholden to some of the outdated views and harmful power structures that are entrenched in other scientific fields.
Yeah, I mean, I really love this. I mean, especially right now when so many scientific fields, institutions are trying to figure out how to kind of either change or reform themselves to be more inclusive and, to reach out, for example, to the computer sciences or the social sciences and to be interdisciplinary and bring more folks from not only different fields, from different backgrounds and different socioeconomic backgrounds. It's really great to see a discipline that basically is doing this from the beginning rather than having to go back and kind of fix the way they started.
I like that perspective that it's a young field, which means we get to decide what it's going to look like in every way. And that includes who practices it and how we interact with each other, in addition to which parts of it we pursue.
Something that I really enjoy about SETI is the way that it forces me to think outside the box and also outside of my brain as a human as much as I possibly can, being a human. So because of that, it kind of exists in this unique position where we can't just look at the data and be like, yes, this is clearly a signal from extraterrestrial intelligence, because this is clearly what they would do. Because we're imposing human bias on that, just by being human. So what we really need is expertise on how humans think, what we do, what human cultures have done and do. And so it's really useful to have input from people who work in the humanities, in sociology and anthropology. And some of my favorite discussions I've had about SETI have been with colleagues in those fields. And I think that's something that is easy to forget or overlook when we work in astronomy and we're in our little siloed departments. But it kind of reveals how much astronomy needs the input from not just astronomers and physicists, but also ethicists and sociologists and anthropologists. And those kinds of collaborations can bring really rich and interesting discoveries and also self-reflections. And so that's one aspect of the field that I think doesn't get highlighted enough in the purely scientific discussions. And kind of along those lines, I think SETI is in a very unique position in that it's such a young field and is in kind of this interesting transition, perhaps Renaissance period, where now we're aware of a lot of the institutional problems with astronomy. We're aware of the history and how that has affected disproportionately people from underrepresented groups. And I think SETI is in a unique position to take that knowledge and kind of make it right, to be a subfield that's on the forefront of making sure we're inclusive, making sure we're diverse, making sure that we're incorporating perspectives from people in all walks of life and people from across the world. Because if we're trying to step out of our brains as humans, but everyone involved in the conversation speaks English, or everyone involved in the conversation is of European descent, then we're not really getting the human experience, are we? So I think it is very important for SETI to be on the forefront of diversity and inclusion. And I think we kind of have a unique position to make that happen.
That's so well said. And, I think that this is a lesson that applies not only to SETI as it's building its practice and its discipline, but also that applies to so many other scientific fields and really all of science as we're looking towards what's to come.
Yeah, so true. So true. I mean, you have to tackle these big challenges. We need, to be as diverse and inclusive as possible.
Yeah, totally agree. All right, folks. Well, that is all from Third Pod from the Sun.
Thanks so much to Kim for bringing us this story, and to Jason and Sophia for sharing their work with us.
This podcast was produced by Kim and mixed by Kayla Suri.
We would love to hear your thoughts. Please rate and review us on Apple Podcasts. And you can find new podcast episodes wherever you get your podcasts, or always at thirdpodfromthesun.com.
Thanks all, and we'll see you next time. Do y'all remember the, like, was it a screensaver, like the SETI screensaver?
Totally.
Yeah, it's called SETI at Home.
SETI at Home. What were they?
Yes.
And they were it was essentially like sharing processing power, right?
Right. There's just like troves and troves of data that there just aren't enough scientists in the world to go through, or computer power like at any one research institute. And so if you installed this screensaver, it would sort of hijack a tiny portion of your computer processor to help go through the data. It was so cool.
I feel like that was a really big thing for a while. Like, if you had that, you were pretty cool.
Why don't
I mean, I felt cool having it, but I don't know if other people thought it was cool.
Well, why don't they have screensavers anymore?
I know. I know. It's like we don't save our screens. We just are in our screens.
Are always at our computers, so the screen never goes dark.
We're gonna start a campaign to. No, we're gonna start a campaign to bring back screensavers.
Save the savers.
Yes.